Okay, we're going to see if we can do this one up this morning. I love this guy's research. It's not so much that it's nuclear physics bound, but what is very nuclear about it is he'll do something at a third phase where it's like what he's doing here is quantum chromodynamics, the programming against quantum electrodynamics, right? Well, there's electrodynamics, and then there's chromium theory, chromodynamics, which is a googly, essentially, that you figure it out. But in sense, let's quantify QED in a way that's a little bit more simple. Obviously, atoms and things like that, but we're not gonna factor that right now. What we are gonna factor right now is that computer chips exist. Now, with that computer, I can make simulators, but I don't know what the basis is at the Feynman diagram to make a transistor. I don't know what it would be to make a resistor. I just know there's ones and zeros traveling through a line, because that's actually the nature of the problem. You don't get voltage always. I have a power supply with a fixed source, or I have a clay pot with grape juice and lead in it, and it's connected in the right way. And so that gives you a charge over time. And so that's that first bit in quantum electrodynamics that you got to parapsychology, quantum mechanics, that really allows you to kind of get into it. So let's take that platform, that catalyst, and let's continue it. Let's say instead of what it is, let's call the breadboard and the circuitries on there what is QED. Now, why would I give that position QED relative to quantum electrodynamics and quantum chromodynamics in terms of what droid training is? Now, we could have the same circuitry design, and you could ask GPT-3 to trim it. Or you could say, given that circuit, I can use that from a shipping container from Japan about, well, I got the space, the box of it needs to be bigger than this, who cares what the computer chip looks in there, I don't even need to use all the circuits on here. And in a way, that polarizes that electron and photon in a way that its full circuitry may not be super efficient, but below the threshold of kind of what's necessary, equally like students and testing. So you get into the photon, make the resistor, the capacitor, the 605 monster chip there, the Raspberry Pi. And essentially, you could say that things travel in a packet.
It is Monday. We're kicking off week 2 of the HUGS program for nuclear physics. Week 1 was super eventful. We've had lectures on quantum chromodynamics, deeply virtual Compton scattering.
There's a version of it where it's like theoretical chemistry versus cellophane. Cellophane would be chromodynamics. Figuring out the metal composition for landing gear on a plane, because it needs to be a different composition, chromodynamics. It has a lot to do with the electrical engineer, or the quantum electrodynamics, quantum mechanics, where quantum mechanics would be that place to the para-quantum mechanics. It wouldn't necessarily be psychological. It would be to a physical index of shear forces in that field, which is basically quantum field theory. Well, it's still field theory, but at the quantum nature of it, it's a little bit more concise than just this moon eclipse, right? It would be marginally, this one should have the next one in the Mayan Hadron Collider clock. This one is the range of lensing, not just of this black hole or galaxy, but of all of the galaxies. The field theory works great individually, and you use a QED for the quantum chromodynamics as a way of describing change E equals
my PhD, and then this whole postdoc thing is going to become
EH,
very real very quickly.
HE?
We just had this platform to ask the presenter tons of questions on CV related things, what we should emphasize, how to become more competitive. It went a little bit long. I'm about to go right into a lecture on gluons in QCD. So it looks like we're picking back up with the QCD lectures, quantum chromodynamics. I don't really know what to expect for these ones.
They're a virtual particle for right now. It's like I factor it like the axion, the gluon. The electron's got to stick to something, even if it's in a air molecule change. Now it'll shift all over in wave function, but you still got to give it a center mass. And that's an axion. It's a
and as a consequence,
what do they call those other ones? Axion and gluon.
Interact with each other.
But with Quantrino,
with QCD, that's
it's a defined model that I gotta have G equal Q, and you do that with something like a gluon. It says the particles, some rational values where I could say hydrogen, helium as a standard model. They follow a spectrum, and that's what the gluon would represent here, but I don't know the purity state. I don't know the decay state. We obviously don't know the motion and position, and that would be the Quantrino relative to its real position. And so if you have the magnets and you have the system, or you have a temperature range, that's going to be in between the pipes. It's going to be just a
so far, I am really
Homer Simpson working the safety gauges.
But you may be wondering, why are there so many talks on QCD throughout the summer
But they're all the same stuff. It's quantum electrodynamics at the end of it. It's still quantum field
I think
theory.
Part of it is because there's a lot of
but it makes it easier. Quantum field theory is going to cover parts, so you'll get through that spectrum. And if you could imagine it on a line, there would be some immediate start. Can't get away from it. Can't get away from it. Then you start to prime number those. And if you take those two things and you lay them over each other, when you have this hot mess. And it's like, it's not that you can't figure that out. It's more of, it takes a high level of
these interactions
anthropology, archaeology, digging up that timeline, taking out fossils. Like, I'd get in there with a shovel and get it done, but I might not get a fossil out of it.
Of what's going on inside of the proton. And in that very small amount of time, we can treat it as if the quarks haven't had enough time to communicate with each other.
I don't work for the Museum of Natural Arts.
In other words, in that small time window, you can treat them as if they're almost free particles, where perturbation theory is appropriate. But at smaller energies, close to around 1 GeV or so, which just so happens to be around the mass of the proton, you can't do that anymore. You can't do perturbation theory. So it's kind of ironic that where it would be very nice to be able to consistently apply probation theory to the system, just so happens to be where it more or less gets thrown out of the window.
Why they thought that they did
things exactly. So that's where people like Lattice QCD specialists come in.
Chromodynamics is what I tell you it is.
Talks, all this is going to be non-perturbative QCD, which is definitely something I don't know very much about, so this is going to be very valuable.
Guys like
and
me
we're
and
about
him
to
are
get
going to stop you
started
from
on
doing
the
stupid
second
shit like
lecture
that.
of gluons in QCD. I think you get the idea there. I don't really like showing the same lecture twice.
You
if
could.
It's split into a couple parts.
You could.
So I'll just see you after that ends.
And yet gravity is going to be around. It's like, you may not believe in gravity, but gravity.
One thing that I've tasked myself to do throughout this whole Hugs program is to try to ask a question every single talk.
Some asshole that is really fucking smart will use that on you at some point in time.
It forces me to pay attention
if
to
you
the
don't
stuff
have
that's
it,
outside of my
you
field.
do not pass
and
those
two,
gates.
even if something is unclear enough to where I'd want to ask a question,
I'm not saying I'm good enough to do it.
It's difficult to know how to phrase it to where the speaker immediately knows what the hell I'm even asking in the first place.
I take whoever it is in Nancy Pelosi and Stone Mill and I show them chromodynamics.
The next talk is going to be on meson spectroscopy.
She will pass.
Mesons are particles made
She'll
out of
be
like
happy
quark
and
antiquark
fulfilled by the
pairs.
time I'm done.
So the pion would be probably the canonical example. And meson spectroscopy, at least to my understanding, is like a way of identifying these different kinds of particles based on their spin, angular momentums, things like that, by looking at the spectrum. And actually, this is going to be on experimental meson spectroscopy. So I'm really excited for this because in the first video, I think I said one of the things I'm most excited for is to learn what else is out there besides what my own research interests are.
When you switch gears to a psychologist and you jump in chromodynamics again.
And I think this is about as far away as from my own
totally different standard model of values that I have set into all those positions already that you are hopelessly
behind. Probably quite a few new things. I'm going into this with very minimal prior knowledge.
Usually with guys like I said, we get out there. Now, he's got a real competition out there. There's some people that really know their shit, could probably blindfold that whole equation down, and that's pretty good. But I want you to take for a moment, and I want you to highly consider, where can you do this?
And I don't have to push them away.
And why have you never thought about it to be that equation?
Changes your whole life.
Now that you've gotten those things close enough to each other, maybe you'll make an idea about, well, I did all this and it was easy. So why is that one so much harder? It takes so much to get that down into one quantifiable space, but did you really do it? Did you graph it? And you realize that the challenge is that when you're over at Fermilab, it's not this damn matrix. It's, I gotta mark down all these problems and figure it out. And it's like, maybe it's do this and that'll fix that one. Organization of field theories to debugging it and back at home. So how are they different? So deep in my heart that you're really a part of me.